OpenTelemetry is an observability framework for creating and managing telemetry data, including traces, metrics, and logs. It helps us to gain insights into the inner workings of our applications, enabling us to quickly identify and resolve performance bottlenecks and errors. Now, you may have heard all of this before, but what does it actually mean and why should you use it? To understand OpenTelemetry, we first need to understand the problem it's aiming to solve. Imagine you're running an e-commerce site and a customer reports an issue with checking out where the page is constantly loading. More and more of these reports are coming in, and you need to go ahead and find the source of the problem. But with a modern application, you may be relying on several microservices, a software as a service, and cloud providers, and all of this can start to feel like a black box when you're trying to find where the issue is actually occurring. Is the problem in the cart service? Is it with your databases? Is it with your payment service? Now imagine you were Uber and you had a microservice architecture that looked like this. Finding the source of an issue here would be like finding a needle in a haystack. Software is getting more complex and issues are taking longer to detect and fix. Now, it's not like we haven't had solutions for this previously. Many people have developed their own ways of collecting telemetry data and analyzing it. This is all developed into what we call observability, and that breaks down into three main parts. First, we have our logs. Now, these are a text record of events useful for specific occurrences, but not overall system health or prediction. For example, logging can tell you that a process failed because your system ran out of memory, but it's not very useful in predicting that it was running out of memory in the first place. This is where we need to use our second tool, metrics. Metrics are numerical data of system state and resource use, helpful for trends and finding a potential problem. So going back to our previous example, the metrics would be telling us what our memory usage was over time, and we could even go ahead and set up an alert so if it hits 90%, we get a warning, or we could even set it to restart one of our servers when it hits 90% so that the problem doesn't occur in the first place. Now, the last tool as well is tracing, and this tracks a request across services and is the most detailed in localizing the source of an error. So if we already have all of these then, what is OpenTelemetry actually solving for us? Well, the previous solutions have been developed on their own. So finding correlations between your logs, metrics, and traces often involved using several services, some proprietary, with each one only containing a portion of the information that you needed. We need a unified telemetry to help us find connections and establish a deep understanding. The key is not more and more telemetry data, it's high quality telemetry data that's needed. Another issue as well is there's been no universal standard. This could lead to vendor lock-in, but it also meant that everyone did telemetry a little bit differently, meaning you may have to be onboarded to a new company's way of things. With OpenTelemetry, telemetry is vendor agnostic, and you can carry it across your jobs and projects. Plus, if you're building something like a library or a service, you can build in the observability for others to use, so we can enable it. And since we're all using OpenTelemetry, your definition of things, your semantics, is going to be the exact same as ours, and the data itself is going to be high quality. The mission statement of OpenTelemetry is to enable effective observability by making high-quality, portable telemetry ubiquitous. So now that we know the problem then, and the aim of OpenTelemetry, let's take a look at how they actually achieve this. At the heart of OpenTelemetry, there is three fundamentals: signals, context, and semantic conventions. First, let's take a look at our signals. We discussed these earlier, and these are the actual data points collected by OpenTelemetry, primarily your logs, metrics, and traces. This data, though, is nearly useless without our context. Context is what provides the vital information about the environment and conditions surrounding those signals, so surrounding your logs, metrics, and traces. This is what answers the questions like when did this event occur, where did it occur, and what triggered this event. The context alone, though, isn't enough to ensure that we have consistency and interoperability. The last piece of our puzzle is semantic conventions. These are established, standardized naming and attributes for telemetry data, and it ensures that the information collected from different systems, from your software as a service provider, your cloud provider, can be seamlessly correlated and analyzed. Essentially, this ensures that your cloud provider's meaning of things, your meaning of things, and your software as a service provider meaning of things is the exact same. We all have the same definition of what that telemetry data means. So with signals, context, and semantic conventions then, OpenTelemetry lets us gather comprehensive, meaningful data about our applications to enable effective troubleshooting, performance optimization, and a deeper understanding of our systems. That is the theory of OpenTelemetry. But how does OpenTelemetry actually help us implement this? Well, OpenTelemetry actually offers multiple ways. It has libraries, it has zero code methods, and code-based methods. I'm going to be implementing this in a Node application, but this should work in most languages today. In fact, here's the progress in each of them. So even if you're not using Node, follow along as I'll explain the important parts OpenTelemetry uses to bring you high-quality telemetry data. So we're actually going to start out on the OpenTelemetry documentation here, as it's a great resource. It's packed with tons of examples, explanations, and all of the definitions that you need. I'll leave a link to this in the description down below. But one thing I do want to show is when it has its definition of what is OpenTelemetry, it also has an important part about what isn't OpenTelemetry. So it says here it's not an observability backend like Jaeger, Prometheus, or other commercial vendors, and it says it's focused on the generation, collection, management, and export of telemetry. Essentially what this is saying is it's not an observability backend, and it never will be. It's not going to be focused on what you do with the data, so how you sort of analyze it. It's focused on making sure the data that you are analyzing is high quality. It's never going to provide you with that nice UI to go ahead and analyze this data. You have to bring your own, and we'll actually be taking a look at this later when we use BetterStack to go ahead and view our metrics and our logs. Now, the last thing I want to point out as well is these main OpenTelemetry components, as this is essentially what I'm about to use and show you how you can implement these, and I just want you to keep them in mind as I go through it, as I'll explain the individual parts when we get to them. But the main ones I want to point out that we'll be using is going to be the APIs and language SDKs, the library ecosystem, and then finally the OpenTelemetry collector here. So let's go ahead and take a look at how we do this. So to get started, let's go ahead and go to the language APIs and SDKs section. And then I'm going to go to the JavaScript section, as that's what I'm implementing. Once we're here, I'm actually going to click into instrumentation here. We go into instrumentation, we can see what the definition of it is. Instrumentation is the act of adding observability code to an app yourself. It then also goes on to say that if you are instrumenting this yourself, you'll need to use the OpenTelemetry SDK to talk to the OpenTelemetry API. Now, to quickly explain what they are, essentially all of the OpenTelemetry code you write starts with the API. It provides a standardized language-agnostic interface for us to create and manage telemetry data in our applications, like our traces, logs, and metrics. Essentially, what that's saying is across all of the languages, the API is going to be implemented in the same way. It's going to have the same methods to make sure that the telemetry data is essentially coming out in the same format. One cool feature I do want to point out about the API though is that it's actually safe to call even if you don't have OpenTelemetry set up. This allows us developers to go ahead and include it in our code, say if we're building out a library, and if someone goes ahead and uses our library and turns on OpenTelemetry, it's going to enable the telemetry collection for them automatically. However, if they don't install OpenTelemetry, it's not going to cause any overhead or any errors. So when we're using the API then, we need to use the SDK. The SDK is essentially what just talks to the API. It provides us with the necessary tools, the libraries for capturing, processing, and exporting our telemetry in all of our programming languages. So you'll find an SDK in all of the languages. But now that I've mentioned that, let's move on to what the instrumentation libraries are. Because this bit here is essentially describing how you would instrument traces, metrics, and logs yourself in an application. But you may not actually have to do this, and we won't in my specific example. Because I already have a logging library, so I've set up with Bunyan, but you may be using something like Pinot or Winston, and because I'm using Express.js, they've actually already created instrumentation libraries for us. So if we scroll down here, there's actually a note about this. So it says you're going to learn how to do this manually, but you're not limited to this kind of instrumentation. Firstly, you can actually do an automatic instrumentation. Essentially, with this automatic instrumentation here, you just go ahead and install 2 libraries, and we'll be using this auto instrumentation ones in a bit later. And then you go ahead and just set up some environment variables, and it can actually go ahead and set up some good traces for you out of the box. But the one that we're going to be using is this part down here. For libraries, your code depends on, so as I said in my example, Express and Bunyan. I don't have to write this code myself, since there may already be an instrumentation library. And if you want to see what those libraries are, if you go to the libraries section here, you can see a list of available instrumentation libraries. If we click into here, it will take you to the registry. And what you can see is the OpenTelemetry registry allows you to search for instrumentation libraries, collector components, and other useful things in the OpenTelemetry ecosystem. It's already set a filter to us for JavaScript and instrumentation. And you can see there's some good examples in here already, like you have an Angular interceptor library, you have a Fastify OpenTelemetry instrumentation library, and a load more. And as I said, there's going to be one for Express as well. If I type that in there, you see there's an Express instrumentation. Again, don't worry if this is sounding a little bit confusing. We will go ahead and use this in a bit in the code. So if I go ahead and go back to where we were with the instrumentation library. So then let's take a look at how we instrument this in our own application then. I just want to point out quickly though, I got this code from the JavaScript getting started page. If you go to Node.js, you'll find all of the code you need to go ahead and get started with telemetry in your app in less than 5 minutes, as it says. Essentially, my application is slightly modified from this, but it's the same thing here with the roll dice endpoint, and we'll see that in a bit. I just want to point that out as this is a great place to start in the documentation. So then here is my really simple Express and Node application. It literally fits on one screen here. As you can see, we have a get random number function. We have an endpoint called roll dice, and essentially that's just going to return the result of that random number there. One thing I do want to point out is, as I said, I am using Bunyan as my logging provider. Essentially what Bunyan does is it prints out my logs in a JSON format, and it also attaches additional information. You may want to use something like Winston and Pinot as well, and OpenTelemetry supports them too. It's important to point out that OpenTelemetry doesn't actually want to be a logging provider in that fashion. It's not trying to compete with Winston and Pinot. It actually wants them to go ahead and add in an OpenTelemetry integration to go ahead and convert that format into OpenTelemetry. So that's pretty much the only difference in my code from the example page that we saw on the documentation. And as you can see, I've added in a load of logging messages as well, just so we can see this coming out when we actually set up OpenTelemetry. But the important part is this instrumentation.ts file. This is the configuration for OpenTelemetry, and you see we've set up a few important things in here. So the main part of this file is actually this SDK down here, and you can see we configure the SDK and then we go ahead and start it. It's important to run this before your application starts, as obviously you want the metrics and the traces to be run before that starts so you can pick up everything about your application. But we go ahead and look in this SDK here. What we do is we first set up the new Node SDK, and this is imported from the OpenTelemetry package. Once we're in here, we then go ahead and set up where we want our traces to be exported to, where we want our logs to be exported to, and then finally our metrics. Essentially, this is saying, okay, I can collect these traces, metrics, and logs, but where do you want them to go? Now, for this example at the moment, I'm simply printing them out to the console, but we'll be looking a little bit later at how we can send this off to the OpenTelemetry collector, so we can send this to any observability backend of our choice. But the final bit is the instrumentations. Now, this is the bit that's actually setting up those traces and metrics for us. What you can see is I'm using get node auto instrumentations. What this is doing is essentially it's importing it from this package up here, but it actually has some of the popular node instrumentations already in that package, and it will detect if I'm using them and try and set them up for me. You can actually click into this to see some of them. So if I go to the TypeScript definition, you can see some of the packages that can be configured here. So you've got the AWS SDK, you've got the Bunyan SDK, which I'm using the Bunyan one. We've got things like instrumentation for FS, GraphQL, and a load of other things. And you can see we've got Pinot in here as well as Winston too, if you're using those logging providers. So that should set up the instrumentation for us. So I don't have to touch the OpenTelemetry API itself or even the SDK beyond this setup here. And the last thing to point out is this resource bit up here. What you can see is I define my resources here, and then I attach it to the Node SDK. Essentially, resources just allow you to add details about your application's environment to your telemetry data. So you can see here, I've added the attribute of service name called Dice Roller, and then I've also added the service version here. And you can see I'm actually importing these from the semantic conventions. So as I mentioned earlier, this is how we make sure that across all platforms, we're using the exact same keys and it's talking about the exact same thing. And you see it even tells you what it should be. It should be the logical name of a service. And if I hover over this as well, it says it's the version string of the service API or implementation. And then it says the format is not defined by these conventions. Essentially, the name here is, but the format that we actually put here isn't defined in the conventions at the moment. And you can see with the service name, it's quite simple there with an example of shopping cart. And then down here, we have an example of 2.0.0. So that is the semantic conventions. So let's go ahead and actually run this application now in a console so that we can see the traces, the metrics, and the logs and how they look in the OpenTelemetry format. So in my console, all I have to do is run the index.ts file. So if I go ahead and hit enter on that, this starts up my server. Now I had a basic logging message using my logging provider that simply said that it was listening for requests. And you can see that down here in this body. But what you can see is it's come out in a massive format here. And this is the OpenTelemetry format that's added in a load of extra information for us that's going to be really useful for debugging. So we go to the top here, you can see it's added in our attributes. It's got a load of attribute names here. So it's got the SDK language that I'm using. And then it's got the process ID. And then down here, we've got things like the process owner, the host name, and then also the runtime I'm on. So it's picked up that I'm on Node.js and on version 20.15. So this is information that's going to be really useful when you're actually debugging your application. Then you can see it's also picked up the instrumentation that I'm actually using. It's attached a timestamp. It's got the severity text of info, which comes from my logging provider. And then it's also got some attributes as well, which also comes from my logging provider. But now let's go ahead and actually send some requests to this endpoint. So on my second screen here, I'm going to go ahead and simply load up the page of /rollDice. And this should go ahead and get a new random number for us. It should fire off a bunch of logging messages. And then we should also see some metrics and traces from OpenTelemetry as well. So if I refresh this page over here, you can see that we got a message of rolled dice 3. Now this was just simply my logging message. But what's come in here now is the OpenTelemetry trace, which was automatically set up using the Express instrumentation library. So I managed to find one of the OpenTelemetry traces here. Now don't worry if this is all a bit too much information for the console. This isn't really the OpenTelemetry use case. As I said, you'd then send this off to an observability backend, and we'll be setting that up in a bit, but I just quickly wanted to show off the actual format of the data here. So with this one, the OpenTelemetry trace that's been set up for us, you can see we've got the service name that we set up, so that was Diceroller. We've got the service version that we set up as well using those semantic conventions. A load of different information about how we could debug where it's coming from, what runtime we're on, what host name we're on, what architecture we're on, and different things. And you see the instrumentation it actually used for this was the HTTP one that they provide, and that was set up for us. And then as we keep going down here, you can see it goes ahead and adds on some attributes here. So it has the URL that was called, it has the host name, the method, it has the user agent, a load of useful stuff when you're trying to debug and find the source of an issue. And then finally, if we keep going down, we're actually going to find our metrics as well. So you can see it has a descriptor for what our metrics are, and this is measuring the duration of inbound HTTP requests. Now you can see that this data isn't too useful to look at in a console. As I said, we'll be sending this off in a bit. But you can see here it's essentially gone ahead and said for our HTTP GET methods, how long it has this inbound HTTP request taken, and it's going to go ahead and get you an average for this as well, so you can get some nice metrics on your application. So now that we've seen this in the console then, let's set it up with a more useful observability backend. So back in the code then, I've made one important change to the setup that we had earlier, and that is that I've switched out my console exporters for the OTLP exporters here. So you see I have one for logs, metrics, and traces. Now, if you're wondering what OTLP is, it's the OpenTelemetry protocol. Essentially, this just provides a consistent way to package and send your application's telemetry data to any monitoring tool that supports OpenTelemetry. And lucky for us, that one is going to be the OpenTelemetry collector. Now, there is great documentation on what the OpenTelemetry collector is here, but simply put, the OpenTelemetry collector is the service that acts as a central hub for receiving, processing, and exporting the telemetry data that you create. It has three main components, as we can see here. First is the receivers. Essentially, this is going to accept data from your applications. So where you just saw in the code, we go ahead and send our traces, our metrics, and our logs to this. So it goes ahead and receives that. Then we have the processors. Essentially, this is going to act as a modifying stage. It can modify the data. It can do some batching. It can do filtering. It can do sampling. And then finally, we have the exporters here. And this just means we can go ahead and send that data now, whether it's been batched, whether it's been filtered, or various things like that. We can send it off to our observability backend. So you can send it to things like Prometheus, Jaeger, or BetaStack. So let's take a look at how we do that. So back in VS Code then, what I have here is the configuration file for the OpenTelemetry collector. In a bit, we're going to be running the OpenTelemetry collector with Docker, but let's take a look at how we configure it first. So as I mentioned, we have those three core parts. So first we have our receivers. Now at the moment I've defined some of the basic ones in here. Firstly, host metrics, I actually don't have to configure anything here. All this is going to do is out of the box, it's going to go ahead and collect metrics on the host system itself. When I'm using Docker, this will work out of the box, as I said. Next, what we have is we have a Prometheus receiver as well. This configuration here is set up so that it can scrape metrics from the OpenTelemetry collector itself. So the OpenTelemetry collector Docker container actually goes ahead and sends its telemetry to this Prometheus endpoint here, so we can actually see some of the data on the OpenTelemetry collector. And then finally, you have the OpenTelemetry protocol, and this is the one that we're going to be using in our application to send our traces, metrics, and logs to the collector here. So you can see we define two protocols here. We have the gRPC one and then the HTTP one. And then in our code, if I go back to my instrumentation.ts, you can see that I've set it up to go to localhost 4318, which is where my collector is going to be running, /traces, /logs, and then /metrics. And that's because I'm sending it over using the OpenTelemetry protocol, as you can see. And then over here, that's going to be received by this endpoint here. So now what we need to do is set up our exporters, our processors, and also the services as well. So let's take a look at how we would do that for BetaStack, but we first need to go ahead and create an account. So you'll see why BetaStack is a great tool for this in a minute, as it has a really nice UI to view all of this and it's really easy to set up. But go ahead and sign up for a free account. Once you've done that, you can go ahead and sign in. Once you're signed in, you're going to want to go to sources down here on the telemetry tab and click connect source. Then you want to give this one a name. I'm going to call this one OpenTel, like so. And then on the platform, go ahead and find the OpenTelemetry platform and click create source. Once this is created, we'll be able to get a key out of this. So we'll have a source token. So as you can see down here, we have this source token. Go ahead and copy this for later. Now let's go ahead and take a look at the BetaStack documentation to see how we go ahead and set up the collector to send our data to BetaStack. To do that then, we'll be using this documentation here. I'll leave a link to this in the description down below, but it actually gets you started with the OpenTelemetry collector if you don't already have that set up. But we're going to go to the already have OpenTelemetry collector setup. You can see we can actually go ahead and select our source token here. So if I search for the one I just created, that's actually going to put it into the configuration for us, so we don't have to actually use the one we copied from earlier. As you can see, it's already put the source token in there. So this is the bit that we're actually going to need to add to our OpenTelemetry configuration. So I'm going to go ahead and click copy here. Then if we go back to VS Code, all I need to do is get rid of these bits here where I have exporter, processors, and service pipelines. I can go ahead and just paste in this configuration here. So now we're essentially good to go to be able to send our metrics and our logs to BetaStack. So let's go ahead and start the OpenTelemetry collector using Docker. So to do that, we're going to be running this command here. Now I'll leave a link in the description down below of where you can go ahead and find this command. It's actually just in the getting started for JavaScript on the OpenTelemetry documentation. Essentially all it's doing though is running Docker. It's opening up those ports that we need to connect to. It's loading in the configuration file that we just set up into the correct place. And then finally, it's using that OpenTelemetry collector image. If I go ahead and hit enter on this, then this should start up the collector for us. And this means that we should be seeing some data going through to BetaStack, but first I need to start up my application. So in a terminal then, I just need to start up my application. Now one thing to point out here is it's actually started, but there's no logging messages. And that's because the way I've configured OpenTelemetry, it's now sending all of it to BetaStack. So now let's go ahead and take a look what this looks like in BetaStack. So back on betastack.com, if you see here, it has some setup instructions. And as I said, we're on the page where we had that source token. If I scroll down now, what we should see is logs received. So we have some logs being received and also metrics received. What this means is we can go ahead and click Livetail here. This is so we can view our logs. And as you can see, we've got the logs coming through. We can go ahead and expand this and we can see all of the attributes that we're getting. We can see the resources on that. We can see the severity number. And we can do a load of cool things as well, like querying based on this and a load of different things. As you can see, it's really nice to have a nice UI to go ahead and filter your logs just to find out where the issue is coming from. And the reason we used OpenTelemetry is because we get so much additional data that we can actually set up these powerful filters with. So if I go ahead and actually hit my endpoint now, so if I refresh the page on the roll dice command, and there we go, after refreshing and just waiting a few seconds, you can see that we got some of that logging information that we were previously seeing in the console through to the nice BetaStack UI here. And what you can see is where it starts with rolling dice, getting random number 3, and then finally the rolled dice of 3. We can click into these and again see all of the various information. So this is why you want to use an observability tool like BetaStack combined with OpenTelemetry, as you can do some really powerful querying and find your issues a lot quicker using a nice UI like this. The final part though to take a look at is our metrics. So if I head over to dashboards, you should see there's actually an OpenTelemetry dashboard that's been created for you. Now this dashboard here is actually for the OpenTelemetry collector metrics that come from Prometheus. As you can see, it tells us the status that it's up. Obviously, we don't have too much previous data here. We can go ahead and change the time range from something like now from 5 minutes ago to now to 10 minutes ago. Let me just change this to something like 2 minutes ago and hit apply. And you'll see we'll get a graph of our CPU usage, the retry queue, the memory allocated. But as I said, this is for OpenTelemetry collector itself. Now, if you do want to go ahead and see your own metrics in the dashboard, we can go ahead and create a new chart. To do that, scroll to the top, click Create Chart. What we're going to use is the drag and drop builder here, but you do have other options. We're going to go to the y-axis. I'm going to click Remove. Now what you'll see is all of the metrics that we have access to in this drag and drop builder. There's a bunch of OpenTelemetry collector ones that are coming out from that Prometheus that we set up, but I do also know that we have some custom ones coming from the Express setup, and they are the HTTP client duration ones. So if I go ahead and use, let's say, the HTTP server duration milliseconds count. Essentially, this should just be the number of requests that have hit my system. If I go ahead and drag this to the y-axis, I can go ahead and leave this as the average and then the rate. You can also change the metric type here to a value or rate as well. So if I went ahead and leave this, if I now scroll down to the bottom, I actually don't want this to be an average, or I want this to be a value here. So that's just going to be the average of all of it. What you'll see here is we now get a view of what the graph is going to look like. And essentially what this is graphing out is all of the requests that have hit my system, just the count of them. So you can see about 10 minutes ago, we had 481 of them. And now what we have is 922 of them. And that's because I've actually set up Insomnia to go ahead and hit this endpoint constantly. So this graph should be constantly going up. But that's how you can configure your own custom metrics in the BetaStack dashboard. Then all you have to do is hit save. And what you'll notice if I go back to the dashboard now, at the bottom, we have my graph. And you could go ahead and create your own dashboard for this information as well if you wanted to, if you wanted some organization of your metrics. So there we go. I hope you now have a better understanding of OpenTelemetry itself. Now, I've only scratched the surface of OpenTelemetry. It is a massive topic to cover, but hopefully that's covered the basics there and the important points being the SDK, the API, the collector, and the exporters on how you can go ahead and set up high quality telemetry data in your applications, be able to forward that to the collector, and then from the collector, send it to an observability backend of your choice, like BetterStack. Now, if you do want to pick a logging provider for Node, do go ahead and watch this video we have here on setting up Winston in Node, or if you want to watch the one that YouTube is recommending, go here. As always, please subscribe and thank you very much for watching.